Hello, my boy. How are we doing today?
Hello Dimitri, I was just preparing myself for our lesson tonight. Why don't we start with a story as always?
As you wish. So, once there was a famous mathematician by the name of Professor G.H. Hardy, who came to visit the Indian mathematical genius S. Ramanujan in a taxi whose number was 1729. In their conversation, Hardy commented that 1729 was a dull number, to which Ramanujan disagreed to explain that 1729 is the smallest number that can be expressed as a sum of two cubes in two different ways. Since then, such numbers like 1729, 4104 and others have been named Hardy-Ramanujan numbers.
All that is fine, but I had learnt about squares and square roots. Now what are cubes? Are those the dices that we play with?
Ha 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 ha! You are quite there, my boy. Come, let me introduce you to cubes and cube roots.
Hello and welcome to Notebook. As Dimitri has already made it clear, today we shall discuss the chapter Cubes and Cube Roots. In the first part of this chapter, we shall deal with perfect cubes and properties related to cubes of a number. Friends, we have all seen a die. It is a cube having 6 faces and 12 edges of equal length. Now, if I tell you that each edge of this die measures 2 centimeters and ask you to find out its volume, how would you do it? For the die having edges 2 centimeters each, to find its volume, we simply multiply 3 such edges, which gives us 2 centimeters into 2 centimeters into 2 centimeters, and find out the volume is equal to 8 cubic centimeters. Now, this 8 cubic centimeter can be written as 2 to the power 3 cubic centimeter. Thus, what we are doing here is finding the cube of one of the edges, which is 2 centimeters. So, the cube of a number is that number raised to the power 3. Thus, if a is a number, then the cube of a is a to the power 3, or a cube, which is equal to a into a into a. So the cube of 5 is 5 to the power 3, which is equal to 5 into 5 into 5, which is equal to 125. Friends, remember how we learned about perfect squares? We have perfect cubes too. If the prime factorization of a number is found, and we see that each of the factors appear 3 times, then the number is a perfect cube. Let us take up some examples. Take the example of 125. When we prime factorize 125, we get 5 into 5 into 5. So we see that 5 appears exactly 3 times. So we can denote 125 as 5 to the power 3 and say that 125 is a perfect cube. Similarly, think of 3375. When we factorize this number, we get 3 into 3 into 3 into 5 into 5 into 5. We see that 3 appears 3 times and 5 appears 3 times as well. So we can denote 3375 as 3 cube into 5 cube, or 15 cube. Another example perhaps, let us take 1728. When we factorize 1728, we get 2 into 2 into 2 into 2 into 2 into 2 into 3 into 3 into 3. So 2 appears 3 times twice and 3 appears 3 times as well. So we can represent 1728 as 2 cube into 2 cube into 3 cube, or 12 cube. Friends, so till now, what we were discussing were all about positive integers. What if we are asked to find out the cube of negative integers? The cube of any negative integer is always negative. Let us see how. Suppose we need to find out the cube of an integer minus p. We simply multiply the integer along with the negative sign thrice. Minus p whole cube is equal to minus p into minus p into minus p is equal to minus into minus p cube, which is equal to minus p cube. So the cube of minus 4 is minus 4 into minus 4 into minus 4 is equal to minus 64. Similarly, the cube of minus 5 is minus 5 into minus 5 into minus 5, which is equal to minus 125. Cubes can also be found of a rational number. So the cube of p upon q is p by q into p by q into p by q, which is equal to p cube by q cube. For example, 3 by 2 whole cube is equal to 3 into 3 into 3 whole divided by 2 into 2 into 2, which works out to 27 by 8. Friends, now let us quickly learn some important properties related to cubes of a number. This is important, so jot it down in your notepads. Cubes of all even natural numbers are always even. Cubes of all odd natural numbers are odd. The sum of the cubes of n natural numbers is equal to the square of their sum. Cubes of numbers ending with the digit 0, 1, 4, 5, 6 and 9 are numbers that will end with the same digit. Cubes of numbers ending with digit 2 ends with the digit 8 and vice versa. Cubes of numbers ending with digits 3 and 7 end with digits 7 and 3 respectively. Cubes of negative integers are always negative. Cubes of numbers which end with 0 end with 3 zeros. There exists only 3 natural numbers whose cube is equal to the number itself. With that concept, we come to the end of our today's discussion. I hope that you have been able to understand cubes and perfect cubes. We shall meet you soon in our second video, where we shall get introduced to the concept of finding cube roots. Until then, Team Notebook wishes you goodbye.